Hi, I'm Paul Beckwith with the University of Ottawa Laboratory for Paleoclimatology. And this particular video is a continuation of my How to Become a Climate Scientist in 15 minutes. So that 15 minutes became 26 minutes, and with this additional video, another 15 minutes. I'm kind of exaggerating with the 15 minutes, but I'm still under an hour, so I think we're still good. So Climate Reanalyzer is a very useful piece of software, and I'm going to go over step by step of how you can, use it to figure out what's happening with our planet. You don't have to take other people's word for it. So basically, if you just Google Climate Reanalyzer and click on the first link, then this is the sort of thing that you get. Now, you can resize it if you just do a Control- on your keyboard. It makes it smaller. Control+ makes it larger. So we'll bring it up to here. This looks good. And what you can see is you've got all these different menus. So if you want to find out what's happening essentially real time today, you just click on that. And there's all these different things that you can see. So you're seeing the planet from this point of view. If you just click on this image, then it gives you different viewpoints. So what we're looking at is we're looking at temperature. And here's the scale both in Fahrenheit for you Americans and for the rest of the world in degrees Celsius. So this is the temperature, color-coded in the different regions. And this is global forecast system data. It's basically the temperature at 2 meters on basically today. So temperature anomaly is a very interesting thing to do. Like I said, you can click on here to move around to all the different parts of the planet. Let's go back to North America. Very cold on the east, very warm on the west, but over Greenland it's extremely warm. So the temperature anomaly is it's the temperature today minus the temperature of the averages. The 1979 to 2000 is a baseline. If you take the average conditions on today and subtract off what's actually being measured today, then that's the anomaly, that's the difference. So this region here is 20 degrees warmer than normal is the anomaly, for example. This region here is between 10 and 15 degrees colder than normal for this given day. Sea surface temperature is also very useful. If we go to Australia, for example, where we're getting major bleaching events, then you can see the water is very warm here. If you go back to sea surface temperature anomaly, the water was much warmer here, and a lot of the Great Barrier Reef was bleached. 95% of the reefs were bleached, and probably 50% of them are died. And this is the largest ecosystem on the planet, so we're in very, very dire straits. We need to declare a global climate change emergency and act accordingly. Precipitation and clouds is another interesting thing. So let's go back to North America. So you can see this is snow here, you have rain here, and mixed precipitation would be in the middle. So we're getting regions here where there's snow and rain and so on. Mean sea level pressure is in millibars. So about 1,010 is nominal. The areas of high pressure are red, the areas of low pressure are purple. So areas of high pressure are stable temperature, stable air. Areas of low pressure are where there's storm activity. Just tap the barometer, pressure drops, a storm is on the way. And these regions are very much dictated by what the jet stream is doing. Precipitable water. This is the water in the atmosphere. If you look at the units, kilograms per square meter. So if at the surface, the particular number in kilograms per square meter, if you go all the way up, that would be the amount of kilograms of water in that little area, integrated all the way up. Surface winds. Here, you can see what's going on, and jet streams are very, very important. And then there's sea ice and snow, but jet streams are very important. So these are the winds at about 250 millibars of pressure. And this is the wind speed. So you're going to higher and higher. So here's basically the jet stream. So notice how there's a big sharp trough here, and this is kind of the ridge. So hot, humid air from low equatorial regions can come north here. So this is very warm and stable air. And the cold, dry air from the Arctic is going to very low latitudes here, giving the East Coast in the spring basically another winter. So there's lots that you can tell here with Climate Reanalyzer. So what else can we do? There's all kinds of things that we can do. These are very useful, the forecast maps. So you can look at different regions. You can pick a particular model. Let's say we look at the Arctic, the 7-day forecast in the Arctic. And if you just click here, this is air temperature we're looking at. And if you just click here to play the movie, you can see it cycle through. Every 3 hours it updates. So this is a model. This is going out from today, going forward in time. And let's just have a quick look here. So this is surface air temperature, 2 meters above the ground. And you can see the infiltration of warm air coming up here as we move out 7 days. Also very warm air up here into the Arctic region. So this has been a common feature. The jet streams act as a wall separating the cold, dry air from the warm, humid air further south, and the jet streams are very distorted. Let's look at the jet streams here. Jet stream wind speed, as we cycle through, and you can see how that's changing. Let's go out a bit, Control- on your keyboard, and so we can see what the jet streams are doing in this region. Okay, so over North America, yes, they're starting to shift over. Remember these guide storms, and you can see the circular movement of the whole system. Let's have a look at some other things. There's all kinds of different parameters. You can get the air temperature anomaly, so let's have a look at that. Okay, so this is over the Arctic, so very clearly you can see what's happening here. I mean, look at, how do you think the Greenland ice is going to do when the temperature is 20 degrees Celsius warmer than normal? And in fact, if you look at let's zoom out a little bit, and look at the Arctic temperature anomaly. Again, this would be compared to this 1979 to 2000 baseline, so average temperatures on this day, and this is what's happening today, and this is the anomaly. So the entire northern hemisphere is very, very warm. The Arctic region is extremely warm, and you can cycle through. And if you look at the hooks here of the warm air going right over the North Pole, basically. As we move out in time. Okay, so this is a model, the GFS model. There's also all these other different models you can look at, and so on. What else can we do? So those are the forecast maps. Let's go back here. Okay, here we go. Move over, whoops. Here we go, let's slide this over. Okay, so those are the forecast maps. There's reanalysis maps. You can go back, 20 years or 30 years or 50 years and pick a particular day. For example, you can look at the weather over the Arctic near the minimum of sea ice, like mid-September or something, and see how that's changed over the years. You can get data. This is daily data, or you can get monthly average data. So the reanalysis is just, it goes back. You can just, just play around, click on the menus, and it tells you, what the reanalysis is, how do you make maps. You can pick the data set, you can pick the parameter, all kinds of different parameters, wind speeds, pressures, temperatures, wind in the horizontal or in the zonal or meridional direction, sea surface temperature, anything you want. And then you can pick the time, whether you want annual data or daily data, start and end, and then you can generate plots. The best way is just to play around with this stuff, and it's all there. This is also interesting. I actually just discovered this as I was flipping through the menus myself. So this is Arctic region. This is the potential biomes in the Arctic. on an annual. So you can see what happens if we the movie's cycling through. I believe, no it's not, so let's cycle the movie through here. So this is a global temperature change relative to today. So this is basically today, and then if it was 1 degree warmer, 2 degrees warmer, 3 degrees, 4 degrees, you know, the ice is all gone. You know, if it was much colder, then the ice is going to lower latitude. You can find out an incredible amount of get information on the planet. There's no need just watching my videos or listening to me. You can do this yourself. What else can we look at? What other in this environmental model, like mass balance, for example. So this is just the, this is looking in the Arctic. Look this, so when it's 5 degrees colder, sort of the peak of the last ice age, you can see how far the ice went down and get different temperatures and things like that. It's all there. Foot or meters / meters. So this is feet, this is meters of water equivalent on the ice. And it's from the environmental change model, right? And you can get the sources from the papers. This guy's particular PhD dissertation looked at this, and the data can all be accessed and is animated. So it's really, you know, let's pick a different region. Let's pick North America, for example. So here we are, you know, 6 degrees colder. Look at how far the ice goes down, and then as the temperature, global average temperature increases, you can see how the ice changes on the planet and so on. So what else can I show you? We'll go back. You can do time series, so you can see how you can, for example, you know, look at so time series is just a graph over time, like temperature over time in a particular region, for example. You can do correlations, so you can pick, in Reanalysis, you can get pressures or temperatures or wind speeds or whatever. So if you wanted to look at a correlation, say, between temperature and wind speed, you can do those plots, you know, for any given years and whatever you want to do. And you know, for example, when it's colder, there's less water vapor in the air, there's less energy in the atmosphere, perhaps the winds are not as strong, it's generally drier in the climate when it's colder. And so there's all kinds of things here. Just play around with it. This is University of Maine, put this together. If you have questions, you can actually email or contact some of the scientists that are working with this data. The last few videos, or a couple videos ago, I did Earth Null School, which is very good for certain things. This one thing that Earth Null School is missing is the surface temperature anomaly, which is kind of interesting. I'm not sure why. And that appears here. And this allows you, you know, you can look back in time on both types of software. There's pluses and minuses. They're both probably the two best programs or websites that you can go to become, you know, you're a climate scientist yourself. And then, you know, you can study a particular region, become an expert in biomes if you want, and then if you see something unusual happening, you can report it on Facebook and Twitter and let the world know. There's loads of data. There's not enough people that are looking at this stuff from a system level basis, and we're going to need more and more people doing this. So have a look at my YouTube channel for my videos. Have a look at my website, paulbechwith.net. This work, none of this work is funded by any group, by the university. I mean, I teach the odd course, get some income from that, so please consider supporting my work. If you go to the main taskbar on my website, there's a please donate button. So please consider supporting my work, and until next time, thank you.